Hello everyone, in this video module we'll demonstrate the autocode generation step from MATLAB controller block and later verify the generated C code using a software in loop block in Simulink. So I'm on Yukon Skybox PC, so I have already opened MATLAB, and let me open a Simulink model. So in this model, the plant I have is a linearized chiller model, which output is condenser water outlet temperature and input is compressor speed, and this is obtained through the system identification toolbox we use for the chiller model. Now the plant I have here and then the controller I have here are both in discrete time domain. So what you can do is you can have your plant in continuous time domain and design your PID controller in continuous time domain and transfer both of these using C2D function in MATLAB, and then use the discrete PID and discrete transfer function to get the discrete system here. Or you can just change the plant in discrete time domain and use a discrete PID controller and just tune it in the discrete time domain. So it's up to you how you want to do it. I have got the discrete PID controller and the discrete plant model here for the condenser water outlet temperature and input being the compressor speed. Now before we start going for the autocode generation, there are two things I want to mention. First one is that make sure your working directory has the writing permission for you, because if you are working sometimes in C drive, MATLAB folders, and especially on the Skybox, you may not have the writing permission. So if you are generating autocode and working with software in loop, you might get errors. The directory I'm working is my user account, documents, and MATLAB folder, and this is smooth for me. And the other part is we are right now we are trying to generate the autocode for this PID controller block. So the name I given for this controller block is SIL52. So whatever name I give for the controller block, and if I generate the autocode for this one, that all the directory and file names will be based on the name of the block, of the block that I give to this one. So make sure they are not overwriting some previously generated files or controllers for some other Simulink models. So if you can make sure that, then we are ready for going for the configuration settings to prepare the system for autocode generation. So next is you can just hear the gear icon here to open up the configuration settings. So first you'll go is on the solver tab. Make sure your solver option is fixed step and discrete, and fixed step size is generally auto by default. You want to change to the appropriate one based on your system's sampling time. Here for the chiller model we are using a sampling time of 0.1, so I made sure it's 0.1. Now after that I just directly go to the code generation tab, and in code generation tab there are a few things. One is target selection, the other one is build process. On target selection you have options for different target language compilers. So you have AutoSAR, ERT for the other version, and then GRT. So there are a number of different options. Now these are based on your specific requirement and a use case. So the one we'll be using for the autocode generation and SIL verification is the embedded coder, that is ERT.TLC. TLC stands for target language compiler. So make sure you select that one. And next part is you can select whether you want to generate your code in C or C++. So I'm generating my code for C, and since I'm just using autocode generation and software in loop verification, I don't need the any hardware target hardware. So if you are trying to generate this for a processor in loop part, then you obviously want to generate which target hardware you want to generate the code for. Now the other one is build process. Basically you select what type of compiler you want to use for this system, so you can automatically locate installed, or you can actually manually select which compiler you want. and the other options are optional. You can use based on your specific requirements. Now these few tabs are reports, comments, symbols, custom code, debugging are the optional tabs. So if you prefer to generate a code generation report, you can select that one. You can navigate, you can choose how you want to navigate the report, how you want to have the traceability options, and then the other tab says about the comments, how you want to comment comments on your C code, whether you want to keep the MATLAB source code as comments or not. And the other tab says about how you want to represent the symbols, custom code, debugging options, and interface. This is still optional for this autocode generation part, but you can select your standard math library for your C environment. And if you are working with continuous time domain, or if you are working with non-inclined S functions, so there are different supports for different types of options for your software environment. The same thing for the code interface and data exchange. Now the other tab is verification tab, because we are intend to use the generated code for a software in loop part. We have to check some options here. So first one is we want to create a software in loop block. So if we are just interested in generating the autocode, we are not required to generate the create the software in loop block. But since we intend to have a software in loop verification, so we want to create a SIL block. And the other thing is, since we are taking the C code back to the Symlink for the SIL verification, we want to enable the portable word sizes, so that the word sizes are consistent between C code and Symlink. There are other ways to do it, but for this demonstration we'll use the enable portable word sizes option. So make sure you create a SIL block and check on the enable portable word sizes. And then the other tabs are optional. You can choose your code style. If you have code templates, you can use those, and same thing with the code placement, data types, replacement, and memory section. So if you go through these tabs one at a time, then you are ready for the autocode generation. Now you can generate the autocode for the entire system or for a specific block. Since we are only interested in a specific this PID controller block, so we just select this block. There are two ways to do it. Basically, you can click on this icon, this arrow button, and then there are build the entire model or build the selected subsystem. So the other way, you can just right click and see the C code, build this system. So I'll just click on this one. And since we are not tuning any parameters in this controller, we are just using one input one output part. So just hit the build button. So you can see that on your directory settings, they already created a folder SIL_v2_ERT RTW. And once the building is completed, you'll get a untitled model with a software in loop part. Now if you double click on this one, it says code generated code is located on this folder, and you can click on the arrow on the left bottom, and you can see that this is the actual CIL block. So this is the software in loop block which basically uses the C code. Now the second thing we want to do in this model is verify that this software in loop, this generated autocode works the same way our controller worked. So what I want to do is go back to my model and select all the module, because I want to create replace this controller block with the software in loop block, and then redo the simulation and see how that will be different from this one. So first thing I'll do is I'll just run the model. So because I have a sync block with model out name model output to the workspace. So this model output will go to the workspace, and I have taken this one as a time series data. So model output dot time will have time information, model output dot data will have the data information for this temperature. So that is already in the workspace. Now I'll control A, select all the blocks, copy, control C, and go back to the untitled file and paste all the blocks. Now I can keep the PID block right below the SIL block, and I'll delete this PID block. Now I'll replace the PID block with the SIL block. Now this is my software in loop model. So I have my plant model from Simulink, and this SIL block is basically the C code, which uses the C code. Now I want to change the name of the variable name from model output to SIL output, and run the simulation. So everything else is same. I just replaced the controller block with a software in loop block, which basically uses the C code generated for the controller. Now the system is compiled and simulation is done. So what I want to do is I have created a small script. So plot model output dot time dot model output dot time model output dot data. So basically this, if I execute this part, this will plot the output for the model with the controller, PID controller. Now the second part is SIL output dot time, SIL output dot data. So this is basically output from the software in loop block for the system. So if I go back to the figure 1, I can see that now I want to insert the legend and see that data 1 is for the model and data 2 is for the software in loop model. So since we can see that the output is exactly the same. So this verifies that the software or the C code we created for the controller works with Simulink and gives the exact same answer. Now you can save your file and the other thing you want to do is, if you want to go to the directory, you can see that SIL to RTW, this is the folder that created all the documents. So you can see that there are a number of SIL files that you can see. So Simulink version coded, and these are the codes, and this make sure they have a lot of header files and other supporting C files too. So this is the actual C code generated for the controller block, and you can always look at the HTML report. So you can navigate through this one. So you can just click on any of the subroutines and you can see what exactly the code does. Obviously this code looks much longer than anticipated for a simple PID controller, but so these are all the files that you can see, reports that you can see for the generated Autocode. This completes the demonstration for Autocode generation and software in loop verification for the linearized chiller plant model. Thank you.